Hello and welcome to the Section 10.2 application walkthrough. In this section we worked on multiplying polynomials, and we really kind of focused all the way up until you got to a binomial times a trinomial. In these first two problems we have trinomial times trinomial, so you're going to do it really the same way, and it's just make sure you multiply everything in the first by everything in the second. Let's go ahead and look at the first one to see what that might look like. So I'm going to go 6n squared times all of it. Okay, it's going to get kind of confusing with my lines here because I'm going to have a lot of sets of them. But so I have 6n squared times 3n squared. 6 times 3 is 18, and that's going to be n to the fourth. 6n squared times negative n will be negative 6n cubed. And 6n squared times negative 1 is negative 6n squared. Okay. I'm going to use my stacking strategy. I know that I'm going to have to combine like terms once it's all said and done. So I'm going to multiply this n times everything over here. Okay, and anytime I get a like term, I'm going to stack it below one that I already have. So here I have n times 3n squared. That's going to be 3n cubed. N times negative n will be negative n squared, and n times 1 will be minus n. Okay, that one doesn't have a like term, so I can't stack it anywhere. The last one I'm going to look at is multiplying this 1 by everything. So keep in mind I said the lines were going to get sort of distracting and confusing, but just make sure that, you know, if you want to, you can cross off these because you've already multiplied them. And really I'm just multiplying 1 by all these. So what that's going to do is I'm going to have 3n squared minus n and minus 1. Okay. Now I can add all those. The beauty in doing it this way is I just add straight down. So here I have 18n to the fourth. That's the only one that shows that. It's the only one to the fourth power. My to the third powers is going to be 6 plus or negative 6 plus 3, which is negative 3n cubed. And then I have negative 6 minus 1 plus 3. So that's going to be negative 7 plus 3, which is negative 4. Negative n plus negative n is negative 2n, and then minus 1 on the end. And that'll be my answer. Okay, so that's what I'm looking for you to do in a problem like that. The next one, very similar. Just use the same strategy and you'll be fine. All right, so for this, I am going to, I'm looking at framing a window, sort of like the last application set of problems. We have, some sort of graphic here that kind of gives us a lot of the information. But let's go ahead and read through it. So the diagram shows the basic dimensions for a window, which has a height to width ratio of 3 to 2. So that tells us that the length is, or the height is 3x, the width is 2x. It could be, or it has to be that way because that's the height. Height to width is 3 to 2. The framework on the window adds 6 inches to the width and 10 inches to the height. So you need that framing on both sides. So it's 3 and 3 on the width and 5 and 5 on the height. When I'm writing for part A here, it says write an expression for the area of the window, including the framework. So you would need to know this in order to know how big of a hole to cut in your wall. All right, so when I'm looking at area, it's just going to be length times, or it would be length times width, but let's go ahead and say height times width. All right, so the height is 3x plus 5, which is just 3x plus 10. And then the width is 2x plus 3 plus 3, or 2x plus 6. Okay. And now all I want to do is distribute. I have a binomial times a binomial. I think of it as foiling. So we have 3 times 2 is 6. X times x is x squared. 3 times 6 is 18. X. That'll give us a 10x, or 20. X in the middle, and then plus 60 on the end. I can combine my like terms. And there I have my expression or even formula for the area of the window. So now what I want you to do is find the area when x is 10, 11, 12, 13, and 14. So I would do it this way and build myself a little table and say that this is x, this is the area. Okay, what is the area when x is 10, 11, 12, 13, and 14? And all you're going to be doing is plugging x into this equation and see what you get. Okay, let's look real quick at the last two problems. On these last two problems, you're just using the area formulas that you're given, and you are figuring out an expression for the area. Okay, you probably won't get a true answer, but I'm going to leave those problems to you. They are a little bit difficult, but definitely manageable after you've done these other problems. Okay, let me know if you have any questions, and good luck on the Mastery Challenge. We'll see you out there.